Hi guys, today let us do a quick revision of the fifth module. Well, first we studied about the rectilinear motion. This included kinematics, which is the study of motion of bodies without considering the forces causing its motion. Then we studied about the kinetics, which is the study of motion of bodies in which the forces causing the motion are also considered. We then looked into various definitions such as displacement, which is the change in position of the body with respect to time from a fixed point, which is then classified into linear displacement and angular displacement; speed, which is the rate of change of position with respect to time, which can be given by distance divided by time taken; velocity, which is the rate of change of displacement in a specific direction, which is classified into uniform and non-uniform velocity; instantaneous velocity, which is the velocity of a particle at a particular instant, say v is equal to ds by dt; acceleration, which is the rate of change of velocity with respect to time, which can be given by change in velocity divided by time interval; uniform and variable acceleration. Then we studied about the different Newton's laws of motion and also derived the various equations of motion, that is v is equal to u plus at, s is equal to ut plus half at square, and v square minus u square is equal to 2as. We then move on to the curvilinear motion of the particles. Well, a particle which moves in a circle with constant speed is said to possess uniform circular motion. Then we studied some of the definitions, that is angular displacement, which is the total angle traced by the particle with respect to its original position along its circular path; angular velocity, which is the rate of change of angular displacement with respect to time; and then angular acceleration, which is the rate of change of angular velocity with respect to time. Then we studied about the formulas and various relations and also the different equations of motion for circular motion. We then studied about the concept of superelevation. This is nothing but the raising of the outer edge above the inner edge of the road by a certain amount to avoid undesirable conditions such as skidding and overturning when there is a curved road. We then studied about the centrifugal and centripetal force, that is, when a body moving in circular path, it will experience an inertial force that acts in the radially outward direction known as the centrifugal force, and an inward external force that will act along the radius of the circle at every point directed towards the center of the circle, which is known as centripetal force. We then found out the expression for the centripetal acceleration and centrifugal force, that is A is equal to v square by r and F is equal to wv square by gr. Then we looked into the different conditions for the skidding on the level road, in which the limiting speed v is given by root of mu gr, and the condition for skidding on a banked road, in which the limiting speed v is given by root of gr into mu plus tan theta divided by 1 minus mu tan theta. Then we also looked into the expression of superelevation for roads and rails, that is E is equal to v square v divided by gr for roads and E is equal to v square g divided by gr for rails. Next, we moved on to the concept of projectiles. Well, a particle projected upwards at a certain angle moving under the combined effect of vertical and horizontal components of velocity is known as a projectile. Then we studied some important terms related to projectile motion, that is trajectory, which is the path traced by the projectile in space; velocity of projection, that is the velocity with which a projectile is projected into space; angle of projection, that is the angle with the horizontal at which the projectile is projected; time of flight, that is the time taken from the projection to reach the maximum height and return back to the ground by the projectile; and then range, which is the distance between the point of projection and the point where the projectile strikes the ground, that is the horizontal distance. We then looked into the equation of the path of projectile, that is given by y is equal to x tan alpha minus gx square divided by 2u square cos square alpha. The expression for horizontal range, that is r, is equal to u square sin 2 alpha by g. The time of flight t is equal to 2u sin alpha by g, and the maximum height of a projectile, that is h, is equal to u square sin square alpha divided by 2g. We then moved on to the concept of relative motion. Well, the motion which is relative to a set of axes which are moving is called as relative motion. Relative motion can be like parallel motion, in which both the bodies are moving in the same direction and are parallel; can be parallel unlike, where both the bodies are moving parallelly but in the opposite direction; and also motion can be in a plane where the bodies are moving in different directions. The relative velocities respectively for the three motions are given by Vr is equal to Va minus Vb, Vr is equal to Va plus Vb, and Vr is equal to root of Vrx square plus Vry square, and the direction tan alpha is given by Vry divided by Vrx. Next, we move on to the concept of motion under gravity. Well, acceleration due to gravity is nothing but the acceleration which is directed towards the center of the earth experienced by a body which is free to move entirely under the influence of Earth's gravitational attraction. The value g is equal to 9.81 meter per second square. At last, we solved the numericals based on the various concepts, that is, numericals on rectilinear motion, numericals on circular motion, numericals on superelevation, numericals on relative motion, numericals on projectile, and numericals on the motion under gravity. Next, we studied about the D'Alembert's principle. Well, this principle states that for any body, the algebraic sum of the externally applied forces and all the forces restricting the motion in any direction is always 0. Hence, this principle can be represented by F minus ma is equal to 0. We then studied the applications of the D'Alembert's principle in various concepts such as in plane motion and connected bodies, including pulleys. Thank you.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.